All right. Hey guys, welcome to our presentation for Arbitrage, which is fast atomic arbitraging. So my name is Noel, and I'm joined with my teammates Ryan, Daniel, and George. All right, so let's just go with an overview of what we're going to go through. We'll start with the project background, talk a little bit about our project design, the description, and ultimately just go through the walkthrough and our results. Awesome. So our background, cryptocurrency. It's been popular over the years. It's lots of opportunity and like a lot of people investing in it. So that's the thing. However, it's known to be volatile and illiquid, which kind of leads us to our project goal, which is arbitrage on Solana.
An effect arbitrage has is that it stabilizes the value of its coins. Once a coin is stabilized enough, it could gain the confidence the general public needs for these cryptocurrencies to be used as an alternative currency.
All right, so essentially what we built is Arbitrage, a system that supports arbitrage bots to conduct arbitrage strategies on multiple AMMs on the Solana blockchain. Our ultimate audience will be a firm that wants to develop their own strategies and test it with our platform. And so our system allows for continuous monitoring for trading performances, the ability to customize transactions, and data analysis, which altogether makes it easy to test strategies and iterate through transactions in real time. So now going into our project, we had a few requirements. One was to gain profit. Second was to swap multiple currencies between multiple liquidity pools, and we do that with 2 AMMs. And after all this, we want insightful metrics in order to go and backtest our data. And finally, we want real-time control with a dashboard to specify our bot strategies.
So our design in a nutshell is this. So we handle 2 AMM platforms, that being Orca and Radium. We have a curated list of 18 cryptocurrency tokens and their respective liquidity pools. We have a near real-time data collection system that is an off-chain process, as well as an off-chain trading bot. This bot takes from the data collection and can also makes atomic transactions for the 2 swaps and also predicts the slippage. And then finally, last but not least, is our reporting dashboard, which gives visible metrics, real-time monitoring to our processes, and allows you to backtest on previous data. So why did we choose this design? So we decided not to go with upstream dependencies, as we didn't want to rely on external aggregators or services. So everything from the data collection to the trading bot are under the same system. If we went with an external aggregator, if they went down or started charging for their API, that would just break the entire system. Also, having the vertical integration for all of these systems lets us sort of quickly iterate and change things as we go. We also decided to go with a mostly off-chain design. This was easier and cheaper to develop. The one on-chain component we do have is a really small smart contract, but it still costs 0.3 SOL to deploy. And we can, with the off-chain solution, we can use languages we're more familiar with, and we can rely on the open source community for a lot of this code, as there's a lot of TypeScript out there.
So let's look at how Arbitrage is built. The green blocks represent modules of the project that were built by us. The process essentially starts with data collection. We pull the Solana blockchain to get the latest rates for both our Orca and Radium liquidity pools. And then the rates are stored in our database. The trading bot runs continuously separate from this, taking in new data from the database as available. If the trading bot deems that a transaction is profitable, they'll send it to the blockchain to be executed. The reporting dashboard gives us continuous feedback into how our bot is doing over time by giving us tools such as profitability charts, backtesting tools, transaction explorers, and configuration options to further adjust the bot strategies. Lastly, the monitoring dashboard is set in place to allow engineers to have a view into the current status of each part of the trading bot and the ability to start and restart processes. So when it comes to data collection, this is a little bit of a deeper dive into it. This is a flowchart of our process. To keep it high level, we gather the liquidity pools of the pools that are configured as ones we want to trade in. This is done by gathering the user configuration from the database. Once we've completed our request to query the rates, we log the latest rates to our database. And this really is the meat of our project, the trading bot. This again is a flowchart, and at the beginning of every cycle, we pull the latest rates from our data collection. We then generate swap routes between every pool and determine profitability. If we think the route may be profitable, we create a swap and rate logging instruction, put them into an atomic transaction, and send it off to Solana to be executed. Once the transaction is finished, if it was successful, we record that in our database. And if it was unsuccessful, maybe perhaps the rate slipped during execution, we then parse the transaction logs, determine error and rate estimates, and update slippage mappings accordingly. This process then repeats.
A reporting part of the system aggregates data from our Firebase databases, Solana's Web3 API, Solscan's API, and some information from Ryan's server where our programs are running. The website is hosted on Firebase as well. It runs on React, and Bootstrap was used for its theming and containers. If you haven't actually seen the actual website, we can show it to you later. Moving on though, we'll talk about some limitations about our project. Our limitations mainly come from the network our system uses. If the Solana mainnet goes down, which it has, it will stop our bots. The amount of information we can send to Solana each transactions are also limited down to its byte sizes. The RPC nodes we use to poll for the rates of currencies are also limited. Finally, accounting for the time it actually takes to send transactions over the network and the amount of competitors also performing arbitrage, getting a profitable transaction is rather tough.
All right, let's go through a walkthrough of a little demo, I guess. So this is our dashboard view on our site. It lets you see sort of what the current balance is, the earnings, and things like that. Down here, you can see what transactions has happened, their signature, how long ago they were, and also like what step they failed at or succeeded at. So like failed at, and also what AMM it failed on. Below is just the successful transactions that happened. So let's just take a look at one of those. So this is an example of one successful transaction we had. This was about 27 days ago. You can see that we swapped for 4 USDC for 119.15 SBR. And then at the end on our second swap, we got 13 cents back. So that's an example of a successful transaction. But arguably more interesting is unsuccessful transaction. So we have a little bit of a transaction detail page for these. Basically, on top of doing our swap instructions, we also included an instruction to an on-chain program that logs the current rate of the pool at that specific time. So that lets us sort of see afterwards how far off we were. So over here in this transaction, you can see it failed at the first swap. And over here on the side, you can see we're trading USDC for lick. We wanted to go from 5 USDC to 549.29 lick. But in reality, the rate slipped, so we ended up getting 542.8 lick back, which is why it's failed over here on the first swap. We can also see the best case scenario. So this is assuming we correctly estimated the rates for both transactions. So even in best case scenario for this particular transaction, if we guess the rate, we would still end up losing 3 cents on this transaction. So yeah, so that's it for like the dashboard and transaction detail page. We also have a monitoring page. This lets us sort of have real-time views into the processes running. So this is the trading bot logs that are going through right now, and you can see the estimated profit per $1 for each of the routes. Right now, it's not doing anything because none of them are above 0. And then we also have a metrics page, which lets us look at past data and determine to see if there was any missed opportunities there. We also have a slippage slider here, which kind of lets us simulate on past data whether things could have been profitable if we did the trade at that point of time. Yeah, so that's it for that demo.
Awesome. So yeah, so ultimately what we showcased is that we built a system to support arbitrage. Now, being completely transparent is our metrics. We've made 30 cents so far, and we've lost $7 for transactions. However, it's been a lot of trial and error. We've sent multiple transactions, but we've learned a lot throughout the process.
Yeah, and to better show you our results, here's our best trend line for our wallet balance over time. Starting on April 7th, in this 5-day period, we gained a total of 30 cents. And if we go to present time, we still only made 30 cents total, but that's like a cent per day. And we'd like y'all to keep that in mind. Yeah, thank you.
Awesome. So yeah, thank you for being here, and we're open to any questions.
I actually have a question. Have you guys looked into like scalability of the strategies so far?
Okay, scalability in terms of strategy. I think our like actual strategy is pretty naive. It's kind of just taking the current rate and then simulating it through what would happen. So not really. We thought about doing like rolling averages for rates and maybe using that, but we kind of just ran out of time, frankly.
No worries.
Yeah, the quick question. Have you guys thought about, also first off, I think it's awesome that you guys are like brutally honest that you made 30 cents and paid $7 in transaction fees. How do you, like, is there anything you could have done to actually make a profit net? Like, do you have any ideas for that?
Okay. I think so. Yeah, we constantly asked ourselves that. I think basically throughout this entire thing, especially in that dry spell where after like the first 5 days we got something, so we got our hopes up, and then it's just sort of stopped. So we've been constantly tweaking things, like in terms of building ideas to get more insights into why. I think one of the key things is are probably our slippage calculations. So like, even though we haven't made much profit in the last week or so because of the new on-chain rate logging stuff, our bot is actually pretty close to estimating the correct rate. So like, while we were off a lot back before by like a few cents, now we're off by less than a cent sometimes. So maybe that would bear fruits in the future. We'll see. But honestly, it kind of did feel like just throwing a lot of things at the wall blindly without necessarily having any ideas on why. I feel like having a little bit more knowledge on like finance could probably help us in that regard. But our system is very flexible for that.
Gotcha.
Sorry, I also had just one more question. For the failure rates, is it just the trade route running out and just getting filled by someone else?
No, it's mostly that the rate slipped. So you can set the minimum amount you expect out for each swap. And so if that goes lower than what you expect, it will just fail there. And because it's atomic, you don't actually lose anything other than just the transaction fee.
Yeah.
Quick question. Just curious. Those $7 you lost. So what are the transactions you've been spending those funds that you lost?
It's all on the swap transactions. I think there's at least 1,000 of them or so. That's basically deploying the smart contract thing.
Oh, okay.
But yeah, it's mostly the swaps itself.
Okay. So
it's across 17,000 transactions, right? So I think every transaction is pretty minuscule.
Okay.